basically, we have done the analysis of algorithms. I do hope that you know already what is the big O, what is the big omega, what is the big theta, the order of growth, the complexity, and how to do the analysis for the algorithms, non-recursive algorithms and recursive algorithm. Now, we move on to the next topic, which is algorithm design technique, also known as algorithm design strategy. Okay, this is also important as part of understanding of algorithms, because design technique may contribute to the efficiency of the algorithms. Here, I'm going to give you an overview of this algorithm first. So you can get the basic thing first. In general, we have many algorithm design technique or strategy, but these 4 design technique are important and common for us to understand. So for this topic, I'm going to give you the overview of first design technique called brute force, including exhaustive search. The second design technique called divide and conquer. The third designing technique called greedy algorithms. And finally, the fourth design technique called dynamic programming. For the first 3 design technique, which are brute force, divide and conquer, and greedy design technique, please take a look of this analogy. Suppose your cordless phone rings, but you have misplaced the handset somewhere in your home. To complicate matters, you have just walked into your home with an armful of groceries, and it is dark out, so you cannot rely solely on eyesight. To describe design technique 1, based on the analogy, to find the ringing phone, you would ignore the ringing of the phone, or you couldn't hear it, and simply walk over every square inch of your home, checking it to see if the phone was present. You probably won't be able to answer the phone before it stops ringing unless you were very, very lucky. But you would be very guaranteed to eventually find the phone no matter where it was. The keyword here is you have to find it. Find the phone every square inch of your home. But the good thing here is you may get the phone even though it stopped ringing. To describe design technique 2 based on the analogy, to find the ringing phone, you would take care of the ringing of the phone and initially walk over each of section of your home based on the ringing to see if the phone was present in that section. You probably would be able to answer the phone before it stopped ringing. You would eventually find the phone where it was in the section targeted. The keyword for this design technique is try to find the phone based on the section. And this is a specific design. Divide the rooms, the home, into many sections and try to find based on the ringing for that section. You may find the phone even though it stopped ringing. To describe design technique 3 based on the analogy, to find the ringing phone, you would simply be to walk in the direction of the ringing of the phone until you found it. The problem here is that there may be a wall or an expensive and fragile bus between you and the phone, preventing you from finding it. So the keyword here to describe this design technique is walk in the direction, which means you have to set a goal and go for it. The main problems or the limitation of this design technique is you may not get the phone. Finally, for algorithm design technique 4, which is dynamic programming, we may not use the same analogy, ringing phones, because it is totally different concept. Dynamic programming basically based on recurrences with some overlapping sub-problem. It solves smaller problem, keep them for future reference, and use the solution to solve the same sub-problem. But to describe it in a simple way, you may take a look of this problem called Fibonacci. For example, Fibonacci 5, you can see many sub-overlapping problems such as Fibonacci 3, Fibonacci 2, 1 repeating. So, if the Fibonacci 3, 2 and so on are already solved, for the next Fibonacci 3, 2 and 1 may use the same solution. So in general, these are the 4 common algorithm design technique, sometimes algorithm design strategy. We have the brute force. Brute force is the default design technique. We have the DC, divide and conquer. We have the greedy, and finally dynamic programming. Okay, these are the difference. For the brute force, these are the default design technique. Basically, straightforward and just do it. This is the keyword. Straightforward mean when you have a problem and you know that how to solve it, usually by using certain calculation or whatever, and we just use, for example, searching in order to search the key. For example, square search. So we have the search key and we need to compare through the list from the index 0 until 1 and do it. So that is actually the brute force. Also for the sorting, we need to compare 2 items. For example, bubble sort, and compare item 1 and item 2, which one is smaller, which one is bigger, then we just swap. So that is the solution, then we just do it. So this is an example of the brute force. Okay, for the divide and conquer, these are quite advanced strategy, because brute force look like there's no strategy, we just do it. But divide and conquer, there is a strategy actually to divide the bigger problem into smaller problem and solve the smaller one. And the division, basically we divide into 2. Most of the algorithm basically divide into 2. Maybe there is a quite rare divide into more than 2. For example, binary search tree is a good example. Divide into 2 sub-array but conquer for the first sub-array or maybe the second sub-array. For the others algorithm, merge sort, for example, or quick sort. So divide into 2 sub-array, 2 sub-programs, 2 sub-problem with certain partition technique and conquer for both. This is a concept of divide and conquer. And solve smaller instance, mean during the division is until the stopping criteria, because it's usually using the recursive. We stop and after that solve the problem based on the small instant. The next is greedy. So greedy is a bit confusing sometimes, because as its name implies, greedy mean we had to find whether the maximum value first or whether the minimum based on the problem. For example, we had the example just now, coin chain because the goal, we have to set the goal and go for it. And for the goal is actually we want to find the minimum or the least number of coins. So of course we have to go for the maximum number of coins first. So that's why here we construct solution piece by piece. Mean we set piece by piece in order to solve it. Mean if a coin chain as example, we go for the bigger coin chain first and reduce it until, for the this algorithm, for the shortest distance with the shortest path, we have to find the minimum first minimum distance and go for it. Okay, and after that, based on the goal, we have the goal. Actually, the goal is to find what? To find the maximum, to find the minimum. These are the greedy style. Okay, and the limitation of greedy sometimes, especially for the optimizations problem, greedy sometimes may not obtain the optimal solution. In certain case, yes, but not for the all cases. And next is a dynamic programming here. Dynamic programming basically is a very good design technique, and this is basically based on the recurrent relation. So based on the recursive technique, and also the recursive actually is solve small instant. It will divide into small, go to the small and solve it. But the main thing of the dynamic programming here is, if we have already the solution, let's say the solution is already solved, we have to record it, and after that we look up that the solution and extract it and use back and reuse the solution, and without repeating the same. This is actually the dynamic programming concept. That's why dynamic programming is become the important design technique. Okay, as overall here, back to the analogy, especially for the first three design technique, for the ringing phone. So ringing phone is actually from the brute force. We just search for the phone without any strategy, and we have to go to every square inch of the rooms to find the phone. For the divide and conquer is based on the analogy, is we divide the room into certain section, and after that we try to go to section that we think there is a phone there. For the greedy, basically based on the ringing phone, we set for that direction. We maybe we think that the phone is from this section. We just go for it without concerning any obstacle and so on. That's why sometimes greedy will face a problem of we cannot obtain the optimal solution. But for dynamic, basically we cannot use the analogy of ringing phone. It's totally different.